Good morning. Mrs. Craven here. Today we're going to walk through together lesson 824, just problems 89 and 90. I did give everyone a copy of this document, so if you want to have it in front of you or copied out and follow along as we go. I also attached problem 92 at the end, which is your homework. That'll be due on Wednesday. So you would have all of the information in the same place. So hopefully you're all ready to go. If not, then I would suggest pausing this video and getting a copy of the document or having it in front of you so that you can follow along in your notebooks. So we're going to get started. 824 is where they kind of pull all this quadratic information together, and we take a look at how we can move back and forth between like a table and an equation. We've gone from equation to graph. We're going to look at going from graph to equation, situation to equation. For the most part, we have moved in this web that we're looking at. We've moved from equation to all the other pieces. But for this, we're going to go ahead and move through coming up with equations that satisfy needs. So let's start with just looking at this. This will be kind of familiar. We covered this a little bit in 886, and if you watched that video, I know 886A was a little tricky. We're going to talk about that again here. We're going to move from table to rule in problem 89. So it says that you know how to make a table for a quadratic rule. If you have the equation, you can just be plugging the values in. You get in here, you take a look at the table, you can see the symmetry happening in the outputs, 6 to 4 to -4 to -6, and then back up again. Same thing with this next table, you can see the symmetry again happening here. On either side of the -9 for the outputs, you've got -8 and then the -5s and the zeros. So it appears to be quadratic. We're going to go ahead and see if we can reverse our understanding of that zero product property and write an equation for each of these. So in the zero product property, that helps us come up with our x-intercepts. And if you look at the table, you've got your x-intercepts here. You've got an x-intercept right here at -3, an x-intercept here at 2. So going in reverse, and I showed this in the video for 886, but if you go in reverse of the zero product property, that means we had two factors where -3 caused the one factor to be 0. So in that case, that would mean that we had x plus 3, because -3 would make that factor equal to 0. And over here we had x minus 2, because 2 would make that factor equal to 0. So in factored form, we think that this could be the equation for that parabola. Now I can go ahead and we can do a real quick multiplication here if you guys want to go through the generic rectangles again. We'd have x squared and 2x and 3x. This is just a real quick, oh, I'm sorry, this is a -2, so a negative and a -6. It's just a real quick review of how we could write this in standard form. Some of you might be doing the FOIL method, and that's fine. So taking a look at this gives us a few more clues. This would give us, and I'm going to highlight in a different color here, this would give us a y-intercept of -6, and we can see that right here. We could test a point if we wanted to. We could test, for example, maybe we put 1. Maybe we put 1 in for x and see what we get for y. So we can try that. So we get 1 plus 1 minus 6. 1 plus 1 is 2 minus 6 is -4, and it checks. So I think that's enough to see that this would be a valid equation in either form, both in factored form and in standard form for that table. So we're going to go ahead and try the second one. Doing the same thing, we would look here and we would say, all right, do we have our x-intercept showing? And we do. There's an x-intercept here. There's an x-intercept here. So we're going to go ahead and follow the same process we did before. We're going to put this into factored form. So for -5 to be a 0 or a solution, that would mean it would be x plus 5 because -5 plus 5 is 0. And for an x-intercept to be 1, it would be x minus 1. So 1 minus 1 is 0. So this is in factored form. We can expand that out, multiply that out. This time I'm not going to do it with a generic rectangle. I'm going to do the x squared plus 5x minus 1x would be plus 4x minus 5. And I'm going to check then, again, that my y-intercept should be at -5, and it is. So those match. I'm going to test. This time I can't test 1, 0 because 1 was an x-intercept. So I'm going to test here at 2, 7. So I'm going to test for x equals 2 and see if this works. So I get 2 squared plus 4 times 2 minus 5. And let's hope that we get 7 as an outcome. So I get 4 plus 8, which is 12, minus 5 is indeed 7. So that point works, and I believe we have the right equation. Another way to test that would be simply to go into, if we wanted to, we could go into our Desmos and we could type in both equations. We could type in y equals, for the first one it was x plus 3 times the parentheses x minus 2. And then we could type in another color the expanded form and see if it matches. Y equals x squared plus x minus 6. Oh, I have something wrong in that first equation, so sorry. Let's say, so you see that they didn't match. Let's make that a plus. There we go. And our two equations then match. Blue, red, exact same equation. And you could do that for the other one as well. So given a table, if you can see the x-intercepts, you can certainly reverse your thinking with the zero product property, which is what we did, and write an equation that way, both in factored form again, factored form, and in standard form. All right, so moving on. We're going to look at problem 90 now. So now, if you guys remember, we've talked about this before, the quality assurance representative at the function factory. We have 3 situations here, 3 different clients who have ordered from the factory, and in each one of those something has gone wrong. And we need to figure out what it is that's gone wrong and try and answer it. Now, what is key here is that we're trying to solve their problem. We're trying to, it says you must reply with clear directions that will solve the problem. You're finding a solution. It doesn't mean it's the exact solution, but it's something that satisfies their need. So when I look at this first problem, it says, I followed all of the directions given in your brochure about how to order a parabola. And I tried to order a parabola that passed through the points 1, 0 and -6, 0, only to have you send me the wrong one. So then it says, please tell me how to order the correct parabola. So there are infinitely many parabolas that could go through the points 1, 0 and -6, 0. We just need to give a suggestion of one that could possibly work. And in this case, this is really a direct application of what happened in the last with the tables. I would address the fact that there are many parabolas that would satisfy this because it would depend on, if you remember, we looked at this briefly. There's this idea of, in factored form, that I'm going to write it like this, that your format has this lead coefficient of A that could make your parabolas wider, they could make them narrower, it makes it open up, open down. So this is what's impacting a problem like this. Now, typically I would just say the client should order, we're just going to apply what we did with the tables above, the client should order this parabola because I can guarantee that this parabola has zeros at 1 and at -6, and that's really all they asked. So as long as you have those two things in place, you have satisfied what they're asking, and that's all you need. So this would be a parabola that satisfies that. There are many more that would, but in this situation, that's all that we need to do, is we need to make sure that that parabola goes through those 2 points. So this would be a factored form that would give them that parabola, or we could, in turn, change this into expanded form, into our standard form, and give it to them that way as well. Either one of those would work. That's for A, knowing that all we needed were the x-intercepts or the zeros of that parabola. So now we look at B. And on B, it says, I'm very dissatisfied customer. I want a parabola that hits the x-axis, only once at 5, 0. And I see no mention of this type of parabola in your pamphlet. Your company mission statement assures me that my... Okay, they're being silly. But ultimately, we need a situation where both of our factors in factored form are exactly the same. They give us the exact same outcome. So we could write this in a couple different ways. We could look at this as being x minus 5 times x minus 5. You could rewrite that as the quantity x minus 5 squared. You could write this out as a perfect square trinomial. We could call this x squared minus 10x plus 25. All of those are equivalent in form. All of those have one and only one x-intercept. 1, 0, 1 root, 1 solution, however it is you want to term that. Notice that there are 4 different ways to talk about that point. It also happens to be the vertex for this parabola. This parabola sits on the x-axis at that point. So that would be exactly what we need to have to satisfy what it is they're looking for. And so we're done with B. We've satisfied their needs by recommending that parabola in whichever form you choose. I personally think this form is the nicest because it really makes it clear that that's what we're looking at. All right, moving on to C. C says, please help. I've searched through your entire brochure and I didn't see a parabola that fits my needs. They want a parabola that looks like this one. So now this one is opening upside down. And it says every time I order an equation, it gives me one. It gives me this parabola. Or I'm sorry. Every time I order an equation to give me this parabola, you send me a different one. So we need this parabola to have x-intercepts at, looks like -3 and at 2. But we also need this parabola to open downwards. All right, so it needs to open downwards. The vertex needs to be up high, not down low. So the x-intercepts at -3, 0 and 2, 0, easy enough to do. I can put those into parentheses where I have x plus 3 and then x minus 2. The problem is that we need this to open down. And right now, if I were to factor this out, it would give me a positive x squared. Like if I were to write that in expanded form, it would give me a positive x squared. And that positive x squared is going to cause it to be a smiling, happy parabola. I need it to be a negative x squared. Easy enough to do. If we go back to thinking about that y equals a times x minus b times x minus c, that setup, this number right here just needs to be negative. So really, all I need to do, I can just throw a negative right in front of the parentheses. And if I were to multiply that out now, so I'm going to take this into expanded form. It'd be y equals, I'm going to keep the negative out here, it'd be x squared plus x minus 6. When I go through that and I distribute the negative into the parentheses, I'm going to get y equals negative x squared minus x plus 6, that looks like it, let's choose a different color highlighting. That looks like that 6 matches that y-intercept of a positive 6, and that idea of the, I'll choose a different color again, the negative is causing that parabola to open down. So just by throwing that negative value in front of the parentheses is all we had to do. And there we've come up with 3 equations. I'll go back through and highlight the equations. We're looking at, that looks really bad, sorry. We're looking at this one for C. Backing up here, we like this one for B. And backing up here, I like this one for A. All 3 of those fit the requirements of what the customer's asking for. And then if you look, I'm done with my presentation. And if you look, you're going to go through that same process for your homework. So I went ahead and copied 92 onto this document. If you've made a copy of it, great. If you haven't, then you can use your ebook, or you can just follow along and work in your notebooks on this. But when you go through, you've got 4 different graphs. A, B, C, and D. And in each one of those, they are similar to the ones that you were given in 90, and you were to come up with equations that would work. If you notice in the setup of the problem, and I want to point this out to you because I know that we'll get questions about it, it says in the setup of the problem, it says determine a possible equation for each parabola. All right, so you want to try and make sure that it fits as best as it can. All right, I hope you have a good day.